So, you think you know what a data engineer does? You're probably picturing someone optimizing ad clicks or tweaking a recommendation algorithm. Well, today we're looking at a completely different kind of engineering role, one that sits at the wild intersection of data science, public policy, and the government, all through the lens of the Open Justice Oklahoma tech stack.
And that phrase right there, that's not just some fancy marketing slogan, it's literally the mission. The idea isn't to build a profitable product, it's to act like a detective, piecing together clues from dozens of messy, disconnected public records to build a true, data-driven picture of how the justice system actually works. It's all about accountability.
So what does that actually mean day to day? What does it really take to do this kind of work? Well, it's a lot more than just writing some code. You have to build systems that aren't just powerful but also deeply trustworthy, incredibly secure, and scientifically rigorous. This is a whole different ballgame than your typical corporate tech job.
So here's our game plan. We're going to break this down into 5 big challenges. First, we'll look at the mission itself. Then, we'll dive into the messy data they have to wrestle with. After that, we'll see how they build a digital fortress to protect it, create pipelines for rock-solid research, and finally, put it all to the ultimate test with a landmark Supreme Court case.
All right, let's kick things off with Part 1, Engineering for Justice Reform. This is all about the why, the fundamental goal that drives every single decision they make.
You hear that term a lot, black box. And for most people, that's exactly what the justice system is. You know, things go in, decisions come out, but how it all works is, well, it's a mystery. The whole point here is to use data to crack that box wide open, making the inner workings visible to everyone, journalists, advocates, and the public.
And this is where you really see how different this world is from your typical Silicon Valley gig. In corporate tech, you're getting data from nice, clean APIs. Here, nope. You're scraping it from ancient court websites that look like they were built in 1998. Your goal isn't profit, it's transparency. And security isn't just about protecting companies' secrets, it's about following strict FBI rules for handling criminal justice info. Even uptime means something different. It's not just a metric, it's about maintaining public trust.
All right, so we've got the mission. But a mission is pretty useless without the raw materials. And that brings us to challenge number 2, the data itself. And, well, chaos is putting it mildly.
Just look at this. This isn't one problem. It's like 4 or 5 completely different, really hard problems all at once. The state court network has no API, so everything has to be scraped and it's full of typos. The Department of Corrections uses totally different IDs for people than the courts. And with 77 counties, you have dozens of different jail systems to deal with. It is a data integration nightmare.
So what does cleaning the data actually look like? Here's a perfect example. When they were looking at eviction data, they'd see the same landlord listed in all kinds of ways. Cobblestone Apps, Cobblestone Apartments LLC, you get the idea. By standardizing all those variations, they cut the number of unique filer names by 12%. That's huge, because without that step, you can't answer a simple but critical question like, who are the top evictors in the state?
So how on earth do you manage all that chaos? Well, you build your own tool. And that's exactly what they did with an R package called OJODB. Now, that domain-specific language part just means they built a custom translator. It's a piece of software that speaks one very specific language, messy Oklahoma legal data. And its only job is to turn that mess into something clean and ready for analysis.
Okay, so you've managed to wrangle the data into submission. Awesome. But now you have another, maybe even bigger problem. You're holding incredibly sensitive information. You can't just drop it in a folder somewhere. You have to build a fortress around it.
For a long time, security in the cloud worked with these things called keys, basically long, permanent passwords. The problem is, these keys were like a master key to the whole building. If one ever leaked, it was a disaster. The new way, Workload Identity Federation, is a total game changer. It gets rid of the keys entirely. The big takeaway is simple. You can't steal a key if there is no key to steal.
So how does that work? It's pretty clever. Think of it like a bouncer at a club. A workflow on GitHub walks up to Google Cloud and shows a special signed ID card, a token that it just got. Google Cloud, the bouncer, checks the ID, sees it's legit, and then issues a temporary access pass that's only good for a few minutes and only for one specific task. The whole process is automated, auditable, and incredibly secure.
And this keyless system is just one part of the fortress. They follow a really strict security playbook.
Every process gets the absolute minimum permissions it needs and nothing more. Broad roles like editor are forbidden, and they can even automatically hide sensitive data like names depending on who's looking at it. All of this is about building and keeping trust with both the government and the public.
Okay, so our data is clean and it's secure. Now what? Now we have to actually do research with it. And this brings us to challenge 4, making sure that research is not just fast, but rock solid and bulletproof.
And this question right here, this is everything. Imagine you publish a big report that influences a new law. 3 years later, a lawmaker challenges your numbers. Can you prove how you got them? Can you hit a button and get the exact same result again? In this world, trust me is not an answer. Reproducibility is everything.
The secret weapon for this is a tool called Targets. See, most analysis code is like a recipe. You have to follow all the steps in order. Targets is different. It's more like a blueprint. It understands how every piece of your analysis is connected, so it sees the whole picture, not just a linear list of steps. And here's where the magic comes in. Because it has that blueprint, it's incredibly smart. Let's say your big data cleaning step takes 3 hours to run, but you just want to change the color of a graph at the very end. Targets knows it doesn't need to rerun that 3-hour job. It just grabs the finished result from its cache and remakes your graph. A workflow that took hours can now take seconds. It's a total game changer.
This whole smart pipeline is wrapped in what's called a CI/CD workflow. All that really means is that there's an automated guard at the gate. Anytime a developer pushes a change, this guard automatically tests it, scans it, and checks it for errors. Only if it passes every single check does the new code get deployed. It's like having a quality control inspector who never sleeps.
So you've built this amazing system. It's clean, secure, and reproducible. It's ready for anything. Or is it? Our final section is about the ultimate stress test. What happens when the real world throws a massive curveball that changes all the rules overnight? That's what happened with the Supreme Court case called McGirt.
So, back in 2020, the Supreme Court ruled that for legal purposes, a huge portion of Oklahoma was still Native American reservation land. And just like that, poof, the entire data model for the state's justice system, which was all based on simple county lines, was instantly obsolete. It was a data earthquake.
This was a massive engineering challenge. Suddenly, they couldn't rely on counties anymore. They had to take raw, messy address data from court records, convert it into precise geographic coordinates, and then check if that dot on a map fell inside a complex tribal boundary. They had to build a whole new system to model overlapping state, tribal, and federal laws, all while the legal rules were still being figured out.
And really, that's what this all comes down to. This quote absolutely nails it. All of this intense, complicated technical work, taming the data, securing it, making it reproducible, and adapting to huge legal shifts, it isn't just about making a faster database. It's about using those skills to build a foundation for a more fair and equitable system. They built this entire architecture of transparency, security, and rigor to pry open one of society's most complex black boxes. And it really makes you think, doesn't it? If you had these tools, this kind of technical power, what black box would you choose to open?